Yes, welcome to electronics online class. In the previous class, we are discussing about the different parameters or different characteristics of your amplifiers, and in that different parameters or different characteristics. If you are studying the amplifiers, it may be any type of amplifier. And the most important thing is about these parameters. As we know, the important thing about the important parameters, one is about gain. Yesterday I said, in general gain is nothing but output to the input, and gain indicates the ability of the amplifier, how much it will amplify the signals with respect to the input signal. And in that gain, we are having so many types of gain. Especially if you are going for amplifiers, you are giving more importance to the 5 to 6 important parameters, characteristics. In that first one is about voltage gain. That is nothing but, as we know about gain, nothing but output to input. But now you are measuring the voltage gain. That is nothing but output voltage to the input voltage. In the same way, you go for the current gain. That is nothing but output current to the input current, and because of both the materials same, you are not having any even for this. In the same way, you go for your power gain, that is output for the input power, and this also you are not having any even for this. Also, you can write yesterday I said about the power gain, that is nothing but AP is equal to AV into AI, because as we know about P is equal to V into I. And look here for your power gain, it is a multiplication of the voltage gain to the current gain. And next important thing about the input impedance, and as we know the input impedance, it is the total opposition offered by the amplifier to the input circuit, or you can say it is the ratio of the S input voltage to the input current, because as you are measuring the impedance or resistance, that is something but they are same. That is something but a ratio of V by I. And if you are measuring input, you can consider input voltage as well as input current, and as you are measuring by ohms. In the same way for output impedance, the output impedance is for, it is also ratio of output to the input, and especially you are measuring the output voltage to the output current. This also the opposition offered by the output circuit, the total opposition offered by the output circuit of an amplifier. And next you are studying about the bandwidth. The bandwidth is so important because by knowing the bandwidth, we can identify how much the bandwidth indicates the ability of the signal, or you can say the band of frequency, the range of frequency up to which your gain will be constant, or the bandwidth indicates the ability of the amplifier, the band of frequency, how much the band of frequency, how much range of frequency your amplifier will amplify the signal effectively. Or another way of your bandwidth is nothing but range of frequency, the voltage gain will be more than or equal to the 70.7% of the maximum gain. That is nothing but your bandwidth, or you can say your bandwidth is nothing but higher frequency minus lower frequency, or you can say about higher cutoff frequency minus lower cutoff frequency. And finally, we studied about the importance of dBs, or as I said here, if you want to measure the gain, if you use your linear scale, it is not possible to measure the gain, because as I said about both the quantities are same, you are not having any unit for the gain. But if we consider the logarithmic scale, we are having the unit for the gain. For your logarithm scale, the unit for the gain is nothing but the bell. The unit for the gain, the unit for the gain will be bell. That is nothing but logarithmic unit. Bell is a logarithmic unit of your gain. And as we know already, why you are given the bell? Because as we know already, the telephone is invented by our Graham Bell. You are given the name of the scientist. They invented the telephone. They are given because they are given about the bell. Especially in your telephone also you are using this unit for the gain, that is bell. And as we know already, the bell is very large unit. That's why we will use the increase of bell, we are using the decibel. We are using the decibel. The decibel is equal to the 1/10 of the bell. The 1/10 fraction of the bell will be decibel. And we know already, if you want to measure the voltage gain, current gain, or especially by using the decibel, dBs, you can compare the two quantities. It may be the two power levels, or it may be the sound signals. The sound can be measured by using the dBs, or if you want to measure the signal to noise ratio, or if you want to measure the signal to noise ratio, or your noise figure, or by using about attenuation, how much the signal attenuated. Also in your communication you are using about the dBs. Actually it is a logarithmic unit. And yesterday I said about if you want to measure the voltage gain in dBs, that is nothing but AB is equal to 20 log the in dBs, the voltage gain in dBs. Then ask for one more question, the voltage gain in dBs, that is something but EV in dB equal to 20 log V0 by Vi, or we can say about 20 log AB. In the same way for AI, for your dBs, that is nothing but 20 log I0 by IR, or that is nothing but 20 log AI. In the same way for the EP in dBs, that is nothing but 10 log V0 by VR, or EP in dBs, that is 10 log AP. It's about you can measure the voltage gain, or can measure the current gain. Also you can measure the power gain by using the dBs. And yesterday I said about the people, what is the necessity of using the dBs, or what is the need for dBs. And especially yesterday I said given the three important reasons. The first important reason is about you consider any amplifier. The output of amplifier is given to the loudspeaker, and as we know the loudspeaker will give the sound, and especially our ears can hear the logarithmic scale. Our ear can respond logarithmically. It means whenever the amplifier will give the some sound, or your loudspeaker will give the some sound, that sound can be measured, or the intensity of the sound can be heard by our ears, but it is by the logarithmically. It means the loudness of the sound is not heard by according to the intensity of sound, but the loudness of the sound heard by our ears is according to the logarithmic intensity of the logarithmic scale. It is not according to the intensity of sound, that is according to the log of log of intensity of sound. And also yesterday I said about if you are using the multi-stage amplifiers and if you want to measure the gain for individual amplifiers, in general we are going for the multiplication, but we go for the dBs, you can add easily the gains. And finally, if you want to measure very high values or very small values, it may be gains, then also it is possible by using your dBs. We can measure very high value of gain or very small value of gain by using your dBs. This is about, yesterday I discussed about important parameters or important characteristics of your amplifiers. And today we go for the most important thing about the amplifiers. Yesterday we discussed already. In the today's class we are going for the so important one 5-mark question for your exam part topic. That is something, but today we are going for the discussing about the single stage amplifiers. We are discussing about the single stage amplifiers. Studying about the single stage amplifiers. It means in your single stage amplifiers, their name indicates their meaning. You are using only one stage of amplifiers, and you said in the beginning you are using the transistors, that is used as the amplifier. It means in your single stage amplifier you are using only one transistor, and also you are using some passive components, because as we know, you studied in the first class, the amplifier consists of three things. One is it contains an active component. It may be your transistor, or it may be amplifier, it may be your FET, or it may be op-amp. And second one is about passive components. It contains capacitor or your resistors. Finally, we want the DC source. It means your single stage amplifier, you are using one transistor and also remaining passive component, maybe your resistor, capacitor, and also you are using about the DC source. And especially yesterday I said about this, we are going for the small signal amplifiers. We are going for the, it is also called, today we are going for the small signal amplifiers, or as I said, depending upon configuration, you have done the three types of configuration. Depending upon the configuration, you have done the three types of amplifiers. One is called common base amplifier. Second one is common emitter amplifier, and third one is about common collector amplifier. Look here, as we know already, we studied about different types of configuration in transistor. We studied which one is common. You have done the configurations. As you studied about different configuration in your transistor, maybe common base, common collector, or your common emitter. In the same way, you can go for the amplifiers. Depending upon the configuration, which one you have done the common for input as well. What are the classification amplifiers? It may be the common base amplifier, common emitter amplifier, or it may be your common collector amplifier. Especially in your, because as we know already, whenever you want to connect any component to the circuit, we want 4 terminals, 2 for input, 2 for output. But as we know already, in your transistor having only 3 terminals, but we want 4. How to make it 3 into 4? Very simple. That is, make it any one common for input as well output. Depending upon when you are done the classification, here in your common base amplifier, the base is common for input as well output. That is called common base amplifier. And in your common emitter amplifier, the emitter is common for input as well output. In the same way, for your common collector, the collector is common for the input as well as output. In these 3 important amplifiers, today we go for the discussing about the common base amplifier. And now we go for the how actually the common base amplifier works, and what are the important characteristics of common base amplifier, and what are the applications of your common base amplifier, and finally what are the drawbacks of your common base amplifier. Because as we know, nobody is 100%. Everybody has some drawbacks, some limitations. In the same way, for your common base also you have some drawbacks. Now we will go for that. First we go for the need diagram. They may ask the question for 5 marks. Explain the working of construction and working of common base amplifier. Explain the construction and working of common base amplifier. And now we go for the diagram, that is the circuit diagram. Circuit diagram of CB amplifier, of your CB amplifier. As we know, now on this side, here we have to make the base common for input as well as output. Now we go for that, and before that we have the need diagram, because as we know already, we are having the marks for the need diagram, and here is your you can apply the base common for input as output, and here you are applying this is your emitter, this is your base, and this is your collector, and here you are applying an input signal, or you can apply here a capacitor, then you can apply here you can apply a resistor, or we can write about lead diagram. Here you are applying the input signal. You are applying the input signal by using capacitors. Using a capacitor, you can apply the input signal, and here you are applying this is nothing but RE, and here applying the negative VE. In the same way, you are applying the input signal VI, that is nothing but you are applying a small input signal, that is nothing but VI. Look here it is your C1, and here in the same way we go for the here you can apply a capacitor, and here we get the output. You get output here. The output will be this is nothing but your V naught. Look here you can get here, you can write about VCB. If you want, you can write VCB. And here you can write about EB, unnecessary. Input voltage, right here. Input voltage. VB, and output voltage. The output voltage will be VC, and important thing here is called RC, and you can apply here positive VCC. You can apply positive VCC, and this is nothing but you are applying negative VE. This is about the importance of your common base amplifier. And the important thing is about here you are applying the C1 and C2, and another important thing about if you apply the cable to the output section, that becomes VCB equal to VCC minus IC into RC. These are the importance about your diagram. And as I said here, first you are draw the need diagram, and you will write 1 or 2 words about the construction, especially in amplifiers. What is the condition amplifier? It may be a common base, a common emitter, it may be a common collector. The most important condition is about the input section, especially in this common base. Which one is input? The emitter base section, because our emitter is input, base is common. The first condition is about the emitter base section should be forward bias, and collector base section will be reverse bias. The collector base will be reverse bias. And how to make it? The input as forward bias and output as reverse bias. Yes, by using your VEE, the voltage across emitter. That VEE that makes the input as it means emitter is in forward bias, and by using your VCC that makes the output that is enabled collector base section reverse bias. And also that is nothing but your amplifier in your transistor in the active region, because as we know, whenever transistor in active region, it acts as amplifier. And by satisfying this condition, now our transistor is in the active region. The most important thing, we want faithful application. Always we want faithful application. As I said in the beginning, the faithful amplification of nothing but you are increasing your strength and the mixed signal. It may be current or voltage, the important thing, without changing the frequency or without changing the shape of the signal. Only you are increasing the amplitude of signal. That is something but the faithful application. And also important thing is about in your Q point. Q point will be in the middle of activation. And how to make it Q point in the middle of activation? By using your RC and RE. By using RE and RC, you can go for the Q point values. By using RE and RC, you can fix the Q point on the middle of the activation. And this is about the construction. And especially, we are applying the input to the emitter base section, and we will measure by using the C1 nothing but coupling capacitor, and C2 also called coupling capacitor. By using the, if you are applying the input to the emitter base section, and by using the coupling capacitor, you can give the input to the coupling capacitor, and we get the output from the coupling capacitor C2, and we get the output from the collector base section. The important thing is about what is the use of C1 and C2. They are called coupling capacitor because yesterday I said they couple the signals from one stage to another stage, or can say they will connect one to another. Especially here, the input signal will be given to the emitter base section by using your capacitor C1, that is called coupling capacitor, and by using your C2, you can measure the output across the C2. And especially one important property capacitor. What is the use of C1 and C2 here in your common base amplifier? They are called coupling capacitor, and we know the important function of capacitor. The capacitor will blocks the DC, it allows the AC signals. And here, by using the C1 and C2, we can only allow the AC signal and it will block or oppose the DC signal. This is about the importance of your construction of your common base amplifier. Now we go for how it works. How it works. Especially if you are not applying any input signal, we are not getting any output. And as your Q point is in the same place. And if you apply the input signal, to the emitter base section, then what happens to the output? Especially as we know already, you are studying in a different way. Especially if you go on here, we can write here. Can write here the input signal, very small input signal, that is 0 Vi R T, and here we can write about the positive obstacle. What is the effect of positive obstacle? what is the effect of the negative half cycle. Look here, as you know already, you are applying the A signal, that A signal having the positive half cycle as well as the negative half cycle. It means whenever you explain about any amplifiers, it will be common base, common emitter or common collector. First, we have to explain what is the effect of the positive half cycle and what is the effect of negative half cycle on the output. And because in your positive half cycle, you are applying input as positive half cycle, and because already you are to make it the emitter base section for OS, you are applying the negative VEE. It means because of negative VEE, that makes your emitter base voltage negative. That makes the emitter base voltage negative. It means if you are applying the positive half cycle, actually what happens? The positive half cycle will decrease the forward bias. Will decrease. And this arrow upwards indicate increase. Arrow in the downward indicate decrease. It means here in your positive half cycle, if you are applying the input signal and you are going for the explain different the positive, I can write about case 1, you can write case 1, you can write here case 2. For your case 1, now we are considering the positive half cycle, and in the positive half cycle will oppose this VBE, because this is positive, is negative. This positive half cycle will oppose this VBE because they are in opposite. You can say about their opposite side. This positive is negative. Because that happens, the forward bias will decrease. It means because of the positive half cycle, the positive half cycle will decrease the forward bias. Because it is negative, it is positive. The considering positive half cycle, it is already negative. That's why what happens, the forward bias will decrease. And as we know, in your common base, yes, in your common base, which one is input? The input will be, yes, the input will be, which one is input? IE will be input and the output will be IC. It means if the forward bias decreases, what happens? The IE, because it is IE will decrease. Because the forward bias decreases, the IE will decrease. And you may ask the question, why the forward bias decreases? Because here it is emitter. Here the emitter emits the electrons. Because of forward bias decreases, what happens? The entering of the electrons to the emitter will be very less. Why the IE will be decreases? Because now in your emitter will emits the electrons, and if the more forward bias, they will get more number of electrons. If the forward bias is very less, they will emit very less number of electrons. That's why what happens? The IE will be decreases. And as we know, if the IE decreases, then what happens? The IC also decreases. Because according to the equation, as we know the equation, what is the equation? The alpha equal to is IC to the IE. Or you can write about, yes, you can write about IC equal to alpha into IE. Right? It means because of IE decreases, IC also decreases, and if the IC decreases, what happens? IC into RC. IC into RC also decreases. And it means here the current flowing across RC decreases. And if the current flowing across RC decreases, then what happens? The voltage, that is nothing but the output voltage VCB will be increases according to the equation. In this equation, this VCC is constant. Here, what happens? IC into RC is decreases. IC into RC decreases means the VC will be increases. Right? That's why I can write about output voltage increases. In the same way, we go for the negative half cycle. In the negative half cycle, totally opposite of your positive half cycle. The totally opposite process of your positive half cycle. In your negative half cycle, what happens? We are applying negative signal. It is also already it is negative. Negative and negative. That makes the forward bias increases. That makes the forward bias increases. Because of the reason is that we are applying you are considering the negative half cycle. In negative half cycle, you are applying negative voltage. It is already negative. Negative and negative, they will be supports. Positive and negative opposes. In positive half cycle, the forward bias decreases because positive and negative, they will be opposes. Now we are applying negative and negative, they supports. That's what happens. The forward bias increases. And as we know, if the forward bias increases, then what happens? Just say IE, nothing but emitter current, input current will increase. And once the input current increases, what happens? The output current IC also increases. And once the IC increases, then what happens? IC into RC also increases. And finally, the VCB will be decreases. Same according to the equation. Here what happens? This IC and RC will be increases. You will get the negative value here. If you get negative value here, it means your VC will be decreases. It means overall, what happens in your common base amplifier? The most important thing in the common base amplifier, the most important property of common base amplifier, the input and output are in the same phase. The input or output in the same phase. It means if you are applying the positive cycle, if you are applying the positive voltages, then what happens? If you are increasing the voltages, if you are increasing the input voltage, the output voltage also increases. If you are decreasing the input voltage, the output voltage also decreases. It means you can say for positive cycle of the input for the positive cycle input voltage, the output voltage increases. For your negative cycle of the input voltage, the output voltage also decreases. It means in your common base amplifier, the input and output are in the same phase. This is about the importance of your common base amplifier. If you are any doubt, you can once again you can see here. It is so important question. As I said, so many times this question asked for your annual exam for 5 marks. I am saying in your board exam, in your annual exam for your second PUC, they asked it so many times. And as I said, so many times you go for your engineering or any other degree, you are studying once again about this common base amplifier. If you want, I can revise once again within 5 minutes. First, you are drawing a diagram and you are explaining about the construction in 2-3 words. Because you are going for the common base amplifier, going for the common base amplifier. And as the name indicates, here the base is common for input as well. This will be your input section as written here. This is the input section, is the output section. I can write about here the VB. If you want, you can write the VB. Or you can write VB. It means the base is common for input and output. And another important point, always you are going for the amplifiers, you are studying the amplifiers. The condition amplifier is that input section forward bias, the output section be reverse bias. And how to make it input section forward bias? By using your negative VE, we can make the emitter base in forward bias. And by using the VCC, we can make the output section reverse bias. And second condition is about in your about your transistor active region. Not only the transistor active region, you have to take care in that active region, in that DC load line, our Q point should be in the middle of the active region. How to make it the Q point in the middle active region? By using the resistor RE, by using the resistor RE and RC. That makes the Q point in the middle of the active region. And finally, the C1 and C2, that are called coupling capacitor. Here you can couple, can give to the input to the C1. You are applying the input signal to the C1 and you are measuring the output across the C2. They are called coupling capacitor. It means they will block the DC, they will allow the E signals. And as you know, according to the diagram, you are applying input to the emitter base section and will measure the output across the collector base section. This is about in brief about your construction and how it works. And as I said already, if you are not applying any input signal, we are not getting any output, as your Q point is in the same place. And if you apply the input signal to the emitter base section, then what happens? Because as I said already, if you go for common base, common emitter or common collector, if whenever you apply any input signal, we have to explain in two ways. Consider what is it, because as we know, in you are applying a signal, an AC signal having the positive half cycle and well as negative half cycle. But you have to explain what is the effect of positive half cycle and what is the effect of the negative half cycle. And look here for your positive half cycle. Consider the positive half cycle. In this positive half cycle, what happens? You are considering the positive half cycle and it is your V is negative, or you can say your VB is negative. It means our input voltage will oppose this VA, or you can say because of your V is negative, that negative value of VE or VB, that makes the forward bias decreases. Why the forward bias decreases? Because you are applying the positive half cycle. That positive half cycle or positive voltage will oppose the negative voltage. That's why what happens? The forward bias decreases. And as I said already, for your common base amplifier, input is emitter current, output will be collector current. It means whenever the forward bias decreases, what happens? The emitter current decreases. Once the emitter current decreases, the collector current, input current and output current decreases. And if the IC decreases, what happens? IC also decreases, and finally the VCB nothing but output voltage decreases. Because by this equation, here this will be decreasing, and this is constant. That's why the output voltage will be increasing. And in the same way, you go for the negative half cycle. In negative half cycle, this is negative, this is negative. This input segment supports the VDA. That's what happens. The forward bias increases, and if the forward bias increases, the input current IE increases, and if the input current increases, the IC, the current also increases, and also IC increases. And important thing is about VCB, that is the output voltage will be decreases. It means in overall, the important thing about common base amplifier, the input output are in the same phase. It means the positive, if your input is positive half cycle, positive going signal, will get the output also positive going signal. If the input is negative going signal, if your input is negative going signal, output also negative going signal. Or another simple way, if in positive half cycle, input load increases, in the same way output load also increases. In the negative half cycle, the input voltage decreases, in the same way the output voltage also decreases. This is nothing but the importance of your common base amplifier. And with your forward, then go for the last about what are the important characteristics. What are the important characteristics of your common base amplifier? What are the important characteristics of your common base amplifier? The most important thing, characteristics of your common base amplifier, you are having the more voltage gain. You are having the more voltage gain, more voltage gain, more voltage gain. In your common base, nearly about they are given the rate number 1500. You are having the more voltage gain. And second point is about you are having the current gain. Current gain is about less than 1, less than 1, less than 1. Or you can say about IE is IC, 100 IC is less than 1. And third point is about the power gain. Power gain is about moderate alternate high power gain. They are given high power gain. They are given about nearly about 30 dB. This we have discussed already. That is something but the 30 dB. And fourth point is about input impedance. Input impedance. Input impedance. That is nothing but very low input impedance. Input impedance is very low. Very low input impedance. Very low. That is 30 to 150 ohms. They are given here. And about output impedance, you can write about here. If you want, you can write 5. The output impedance is about output impedance is very high, nearly about 500 kilo ohms. The output input is very high, and finally about input or output same phase. Finally the input and output are in the same phase. Same phase. These are the important characteristics of your common base amplifier. And we may ask the question, sir, why you are using the common base amplifier? Whenever we want the more voltage gain, we are going for the common base amplifier. And why you are having the very less input impedance? Because of your input section is 4 waves. And why you are having the output input is very more? Because of your output section in the reverse bias. And another important thing is about especially this your common base amplifier, where you are using this. These are the important characteristics. Once again, repeat. Where I just said, you have studied about in the beginning class. We are giving importance to the different parameters: current gain, voltage gain, power gain, input impedance, output impedance. And here, for your common base amplifier, you are having the more voltage gain, nearly about 1500, and about current gain less than 1 or nearly equal to 1, and about power gain nearly about, you can say moderate or can write say about high, that is about nearly 30 dB, and about the input impedance is very low, it may be 3150 ohms they are given in your book, and about output impedance, that is about, it is very high, that is about nearly 500 kilo ohms, and finally the input and output are in the same phase. These are the important characteristics of your common base amplifier. One is, once again repeat, voltage gain is very more, current gain less than 1, power gain is moderate, and you are having very low input impedance, more output impedance, and input output in the same phase. These are the important characteristics of your common base amplifier. Now we go for what are the applications where we are using exactly the common base amplifier. I just said the most important thing about common base amplifier, it is used for high frequency for the voltage amplification. Whenever you want more voltage amplification, especially in video amplifiers or in your RF radio frequency amplifier, yesterday I said about your ultra high frequency or very high frequency amplifiers. Whenever you want more voltage gain, in that time you are going for the common base amplifier. And also you are studying in the next topic about differential amplifiers, especially in your op amps. If you are studying operational amplifier, you are using the differential amplifiers. In differential amplifier also you are using about the common base amplifiers. And finally, what are the drawbacks or limitations of your common base amplifier? The most important thing, drawback, is about especially we are going for the amplifiers, but this common base amplifier, it is not amplifying the signal, but it attenuates the signal. The most important drawback of your common base amplifier, it will not increasing the signal, or it is not increasing the current, or it is not amplifying signal, but it is attenuating the signal. And you may ask the question, why sir it is attenuating signal? Because as I said here, your the current gain in your less than 1 for your common base amplifier, right? And because of this reason, the current gain is very small, or it is less than 1 or equal to 1. And for example, if you are, as we know about your input as we know in the input section, that is IE in your input and IC, the IC in your output. Actually, what happens here, as we know the alpha, the current gain in your common base amplifier, that is nothing but IC output to the input. And why the gain is less than 1? Because in your common base amplifier, I is more as compared to the IC. The input current is more than the output current. For example, if you apply your example, you take the current, input current is about 1 amperes, but output current will get nearly about 0.95 or 0.98 amperes. It means actually you are applying the 1 amperes, but you are not getting 1 ampere. It will be attenuated. It means if you apply, for example, considering general, if you apply 100 amperes, but you are getting only 99 amperes as a output. Whatever you apply the input, that is not coming to output. Still the less output coming to output. That's why the current can be less than 1 for your common base amplifier. And another reason, as we know already about, you consider any transistors. The important thing is about it may be the NPN, or it may be the NPN, or it may be the PNP, or it may be common base, common collector, common emitter. The important thing is about always the emitter, IE is more, and IB is less, and IC is moderate. Because of this reason, especially as I said, your alpha equal to IC by IE. You are having the bigger of this reason, always the emitter current is very more as compared to the collector and base current. That's what happens if your denominator very more, you get the alpha is very less. It is nearly about alpha value is about nearly less than 1. It is less than 1. This is about the important why. It is another important thing. It is used for the current buffer amplifier. It is used for the current buffer amplifier. Whenever you want the constant current. Whenever you want the same current for input as well as output, in that time you are going for the common base amplifier. It is also used for current buffer amplifier, because your input as well as output has the same current going from input to output. It is also called as the current buffer amplifier. Buffer amplifier. This is about your common base amplifier. The most important thing about the drawback of common base amplifier, it is not amplified signal, it attenuated signal. The reason behind this, always we want the, as compared to the, tomorrow going for in detail about common emitter, common collector, compared to the common base and common emitter, common collector, your input is very less. Why you are not giving more importance to the common base amplifier? The reason is that your input section is very low input impedance. In your common base amplifier, you are having a very less input impedance. That's why you are having the drawback of your common base amplifier. And one reason is why we want more voltage gain. As in your common base amplifier, you are having the more voltage gain. The reason is that you are having the more output impedance. You are having the more output impedance. If you have a very small voltage as input, it will get a very more voltage output. That is because of the you are having the more output impedance. This is about the common base amplifier, and in the next class we go for the common collector and remaining common emitter.